Today we will be documenting the eruption of Mount St. Helens on May 18, 1980. The eruption of Mount St. Helens was a tragic event in Washington.
Located in Washington, the elevation is 2,549 meters. The longitude and latitude of the mountain is 46.2 degrees north and 1,222 degrees west. Mount St. Helens is a stratovolcano. Plate tectonic. The earliest eruption was 10,000 BP. The oldest historic eruption was in 1831. The most recent was 2008, and the number of eruptions in the 20th century was 5. Plate tectonics.
The Earth has many layers. The four main layers of the Earth are the crust, the mantle, the outer core, and the inner core. In 1912, Alfred Wegener developed his theory for continental drift. The outermost layer of the Earth, known as the crust, is theorized to be separated into many different pieces, each referred to as plates. This theory is known as plate tectonics, and these are the tectonic plates of the Earth. It is said that long ago, all the continents formed one supercontinent known as Pangaea. The following is an animation of how the continents are said to have spread from Pangaea to present day. To support his theory of continental drift, Alfred Wegener searched for fossils on both the western portion of Africa and the eastern portion of South America. This is the Mesosaurus, found on both continents. Hotspots are formed when the Earth's crust is thin and magma seeps through the surface. When a tectonic plate moves over this hotspot, it forms a volcano that cools over time. This usually happens at plate boundaries. As the plate moves, it creates more islands. These islands are arranged by increasing age. The Hawaiian Islands are not associated with subduction zones or spreading centers. The islands do not move. When a tectonic plate moves, the islands go with it. In order to contradict plate tectonics, in the Hawaiian island chain, there is one island that is younger than most others, but is farther than the other young islands, contradicting the theory. This anomaly is not because tectonic plates aren't present. This island could have formed through a second branch of magma that... Imagine this square is a tectonic plate moving east. It will create three different types of boundaries. The first we'll be observing is a transform boundary, here, and it is caused when two plates move apart. The second is divergent, when the two plates pull apart, and the third is convergent, when they all go together. These plates are known as transform, convergent. This is a subduction zone. As one plate moves beneath the other, the end of it begins to melt and the magma rises, forming volcanoes. This is known as a subduction zone, and this is how Mount St. Helens was formed.
Formation.
The process of the collision of the two plates, the oceanic and the continental plate, was slow-moving and a long process. The formation began with the subduction of the oceanic plate, the Juan de Fuca, beneath the continental plate, the North American. This occurred because the weight of the water of the oceanic plate increased the density of the oceanic crust. This process continued for hundreds of thousands of years until it got to its current size. This is a time-lapse video of Mount St. Helens growing from November 14, 2004 to February 28, 2008.
Geography.
Mount St. Helens is one of the most active volcanoes in the U.S. Pacific Northwest region. It is also part of the Cascade Mountain Range. Land surrounding Mount St. Helens is mostly preserved and is part of the Mount St. Helens National Volcanic Monument. The main river systems surrounding Mount St. Helens are Kalama, Toutle, and Lewis River. These rivers are significant because they were an impact to the eruption. The town nearest to the mountain is the town of Kubir, which is 11 miles away.
Cause and effect.
Mount St. Helens is less than 37,000 years old and has been active for more than 4,000 years. Since the 1400 AD, eruptions had occurred 1 per 100 years. These eruptions generated explosive pyroclastic eruptions. Small eruptions that occurred before the eruptions were steam eruptions generated by the heating of the groundwater above a rising plug of magma that took over the central conduit of the volcano. Mount St. Helens sits on a plate boundary between Juan de Fuca and the Northern American Plate, which are part of the Ring of Fire. The destructive nature of the margin between the Juan de Fuca and the North American Plate caused the subducting of the Juan de Fuca beneath the Northern American Plate, which caused a big eruption. As the Juan de Fuca was submerging, seawater was pulled to the subduction zone, which came in contact with the magma and generated steam. Scientists expected the explosion to occur in the main vent, but because of the big landslide, it occurred on the side of the volcano. The Mount St. Helens eruption was a catastrophic eruption and caused much damage to the wildlife around it, mainly from its tremendous ash cloud. The ash cloud spread so rapidly that it reached eastern Washington, 195 miles away from Mount St. Helens. Nearly 2 inches of ash covered the ground, which is only half as far from the volcano. The debris and lateral blast created a crater 1 mile by 2 miles wide and 2,100 feet deep from its rim to the lowest point. After the eruption, the highest point on the volcano was about 8,364 feet, which is 1,313 feet lower than the former summit elevation. Mudflows and floods were caused by the eruption. On the upper slopes of the volcano, the mudflows traveled as fast as 90 miles an hour. After the volcanic activity stopped and all the aftermath was done, there was a total of 57 deaths. Most victims died from inhaling hot volcanic ash. All buildings and man-made structures in the vicinity of Spirit Lake were buried. More than 200 houses were destroyed, leaving many homeless. Thousands of acres of prime forest were either destroyed or heavily damaged. More than 185 miles of highways and roads were destroyed or extensively damaged. Many land and water animals were destroyed during the eruption, but most survived because they were either below ground level or water surface. Many agricultural crops survived, but most were destroyed.
57 lives were lost. Damage cost was $1.1 billion.